Now next we're going to discuss finite automata. Now finite automata is an abstract computing device. It is a mathematical model of a system with discrete inputs, outputs, states and set of transitions from state to state that occurs on input symbols from sigma. That means finite automata can consist of states and their transitions. Now these transitions are based on input symbols. So this is what our finite automata. It can be represented in three ways. We can say graphical representation, we can say it as transition diagrams or transition table. Tabular representation is again the same transition table, and mathematical representation we can say transition function or mapping function. So what this transition diagram is, what this transition table is, we're going to discuss it. Now first we'll discuss the formal definition of finite automata. Finite automata is a model consisting of 5 tuples. That the tuples are m is equal to q, sigma, delta, q naught and f. Now what each of these is. This is the formal definition of finite automata, that is q, sigma, delta, q naught and f, where q is a finite set of states. We can say whatever states we are having for that particular automata, we have to include, or all are included inside set q. Sigma is what? It is a set of input alphabets, we can say. Whatever inputs that automata is taking, all are grouped inside this set, that is sigma. Next is delta, that is the transition function, which is for finite automata. It is q, that is state, current state over an input alphabet is giving us new state. So we can say that this is our transition function, that is delta is q cross sigma giving us q. Now here the first q is the current state and this q is the new state. Now q naught is the set of final state, starting states whatever we have, all those states are there inside q naught, or q naught is the initial state which belongs to again q because it is one of the state. Now f is the set of final states or acceptance states, we can say. Acceptance states, and what this acceptance is we will discuss. Now we can say that f is a subset of q because f is what? Set of final states. So again there are states, so we can say that it is a subset of q. Now first we're going to discuss the representation of finite automata in terms of transition diagrams or transition graph. It is a directed graph associated with the vertices of the graph corresponds to the state of finite automata. That means in this graph we can say the vertices are nothing but the states which are there inside this finite automata. So if you observe this diagram, we are having three states like q0, q1, q2. Now in a finite automata, initial state can be represented like this with an arrow, and the final states can be represented with two circles. Now these are the transitions. With the help of the arrow, whatever we have provided, we can say that it is a transition. Now there is a transition from q0 to q1 on input 1. We can say the 0 1 with whatever you are seeing here, this is nothing but input. So this is the initial state and this is the final or acceptance state. Now 0 1, we can, by observing this diagram, we can see that inputs are 0 and 1. So this is the set of inputs. q0 we can say it's a final state, initial state. q1 we can say it's an intermediate state, and q2 we can say it's a final state. Now see here, this is the transition table for finite automata. It is basically a tabular representation of the transition function that takes two arguments, that is a state, the state in terms of initial and final state, and a symbol. and returns a value that is the new state or next state. Now in a transition table we can say that rows corresponds to states, columns corresponds to input symbol, entries corresponds to new states or next states. The start state is marked with an arrow, and the acceptance states, or you can say the final state, is marked with a star. Now check here the table. Now if you check these rows corresponds to the states and columns corresponds to the input symbol. Now check the entries in this table. Q, that is current state, on some input symbol is going to the next state or new state. So this is the entry in the table, that is next state or new state. Now check here, arrow is there, that means this is the initial state and this is the final state, that is represented with the help of a star. Now see here, the transition diagram or some finite automata is given over here, in which we have two states, that is Q1, Q0 and Q1. By observing the diagram we can say that there are two input symbols, that is 0 and 1. So we can say here the arrow is there and here two double circle is there. So we can say that this is starting state, that is initial state, and this is the final state. So Q0 is initial and Q1 is final, we can see. Now we have to extract the transition table from this diagram. Now check here, if we are in state Q0, so here in a transition table this column is going to represent input symbol. So here we have sigma in this way and here we have Q like this. So Q0 and Q1, only two states are there. This is the initial state, this is the final state, and these are the input symbol. If you check, we are in Q0 and when the first input we observe, it is 0. When we observe Q0 on input 0 is coming back to the same state. So we have to write the new state, that is next state, as Q0, because Q0 on input 0, Q0 on input 0, it is coming to the same state. So here we have to write Q0. Now Q0, that is this one, on input 1, Q0 on input 1 is going to the new state, that is Q1. So this will be the next entry in the table. Now we have to check for the next state, that is Q1. Q1 on input 0, Q1 on input 0 is coming back to the same state, so Q1. Again Q1 on input 1, again it is coming back to the same state, so Q1. Now next here we have specified the transition function for this particular finite automata. Now check here, Q cross sigma is giving us Q. So this Q is the current state, cross, this is input symbol, and the next, that is, this is the new state or next state. Q0 on input 0 giving us the same state, Q0. Q0 on input 1, Q0 cross 1 is giving us Q1, that is this transition. Then Q1 on 0, Q1 on 0 is giving the same state, Q1. Q1 on 1, again it is giving the same state. So this is what the transition diagram, you can say transition table, and this is the representation of transition function.